Welcome to my book review of Quantum, Einstein, Bohr, and the Great Debate Around the Nature of Reality by Manjit Kumar. Just got to finish reading this book. I want to talk a little bit about it. Cover some of the highlights. I'm not going to cover every word. It's a long book. At least you get an idea. I'm going to kind of thumb through the pictures first. I think that would really kind of just almost tell the story. This is of the 1927 Solvay Conference in Belgium. It was put on by an industrialist who funded the whole thing. There's Einstein and there's Niels Bohr. They're going to be our two main characters in this story. There's Marie Curie and then Max Planck, it looks like. And there's all the other big names in it. That might be Dirac. All the big names in physics were there, and it was kind of a meeting of the minds on quantum mechanics. Okay, this is the guy that kind of kicked it all off. This is Max Planck. He was German. Around 1900, he came up with a theory to explain what's called black body radiation. That was driven by the lighting industry at that time. Electric lights were becoming all the rage all over the world, and all the chief scientists were trying to figure it all out. And he had to come up with this idea of the quantum of energy, which was a change, and that kind of kicked off the whole idea of the quantum mechanics. So he kind of started it all just out of trying to make things work. And this is Ludwig Boltzmann. He was big on statistical theory and the atom, and really when the atom wasn't that popular, it wasn't that big an idea. And this was Einstein and a couple of his buddies. They worked together and kind of had a little group that studied together back when he was a young man, probably in his 20s. Okay, there's Einstein in 1912, and this is 7 years after the Annales Mirabilis. So that's the big year. That's when he published all of his, well, not all of them, but several papers, like on the photoelectric effect and the Brownian motion. That kind of was his big burst on the stage of special relativity. Okay, this is the next conference. Let's see what this is. This was just a meeting. The first Solvay conference in Brussels, 1911. Okay, that's when they first started. Like I said, this industrialist paid for all these. There's Einstein again. That looks like Rutherford. There's another guy that looked like Rutherford. I need to check the description. That might be Rutherford too. A guy with a big black mustache, Marie Curie. And then they all got together, and this industrialist paid for a nice hotel for a week there and treated them well, and they got to work on mostly quantum mechanics. That was kind of the big rage, trying to figure out all what was going on inside the atom. Okay, this is Niels Bohr. He's the other main character in this story. And Bohr was a Danish guy, and called the Great Dane, and he was a famous scientist, also a famous physicist. His family was real academic. His brother, I think, actually won in soccer in the Olympics, and he was very athletic, kind of a big man, and he was really sharp and developed much of what we know in quantum mechanics, especially it's called the Copenhagen interpretation, which we'll talk a little bit about more later. This is Ernest Rutherford from New Zealand, and he also worked, Bohr, when he was a young guy, just out of school, I think he might even be working on his PhD, worked for Rutherford there at Cambridge in the laboratory, and kind of helped him interpret. Rutherford was doing a lot of experiments on the internal workings of the atom, and nobody really understood it. His predecessor, J.J. Thomson, had discovered the electron, and so Bohr was a theoretician kind of helping Rutherford figure out what's going inside the atom. Okay, and here we have a kind of famous picture of Einstein and Bohr walking together, and that's during the 1930 Solvay conference. And what they were doing, Einstein was trying to, they both had kind of developed different ideas on this quantum theory. Both agreed that it worked because it did a lot of experimental evidence showed that it worked, but Einstein thought the theory was maybe not complete. And Bohr, who was kind of he ran the Copenhagen Theoretical Institute there, and he had developed this, it's called the Copenhagen interpretation of quantum mechanics, and he adhered to that, and Einstein really didn't like it all that much. He thought it was kind of an incomplete theory, and so those two kind of jousted. They were actually, I think, fairly good friends most of the time. Here they are talking again, and this is Prince Louis Victor Pierre Raymond de Broglie, basically. He was a kind of a wealthy aristocrat guy, but was also a scientist, and he came up with a de Broglie wavelength for like particles, giving particles a wavelength. And you've probably seen that equation in the physics books. That was his, what he contributed. That turned to be really important. Okay, this is Wolfgang Pauli, and he did the Pauli exclusion principle, and by determining where the electrons could fit in the atomic shells, that determined the chemical output of the chemical nature of an atom. And basically the periodic table came out of this idea of the exclusion principle. And he was also called the wrath of God. Apparently he was just real sharp, and somebody said something stupid, he thought it was stupid, he'd let him know. And that's why they called him the wrath of God. Let's see, what are these guys here? Okay, this is Göttingen University. Okay, just different ones. And okay, I see a name there, Emilio Segre. He was part of the, helped Einstein write that letter to Roosevelt in 1941, I think it was, about the atomic bomb, warning Roosevelt to get the atomic bomb going. And so he was also a scientist with this group also. Okay, and this is another group of scientists here. Yeah, Emilio Segre, and that again. Okay, this is Heisenberg. He was big on the matrix mechanics, and he worked with Bohr, but he kind of went off on his own and came up with this matrix idea to describe quantum mechanics in terms of observables and matrix mechanics, which they didn't really know, but basically linear algebra now. But they didn't know much about it at the time, or at least it was just kind of an area of math, and most scientists didn't know much about it. He actually went on to run the German nuclear program during World War II, and they didn't really know that, but later on he kind of told everybody, yeah, that's what he did, but he really wasn't behind it, and he said his spirit wasn't in it, so he didn't progress as much as he was hoping, or the management, Hitler, was hoping. So that's what he went on to do, being in quantum mechanics and also in World War II. So here's Bohr, Heisenberg, and Holly deep in conversation over lunch at the Bohr Institute, the mid-1930s, Niels Bohr Institute. So that was there in Copenhagen. They're having a discussion. And this was Paul Dirac. He was also big in the development of quantum mechanics. Okay, here we go. Okay, this is Schrödinger. Okay, Schrödinger came up with an alternate theory of quantum mechanics that has to do with the Schrödinger wave equation. And there's two ways of interpreting this. Was one with it in terms of waves, and one would be like where the outcomes were the Heisenberg matrix approach. So they were kind of competing, and Heisenberg and Schrödinger kind of jousted with each other on who had the correct interpretation. Come to find out they're both mathematically equivalent, but they had two different kind of approaches to the whole subject. Apparently there's more than one way to skin a cat on this. Okay, let's see. This is Dirac shared the Nobel Prize, and Heisenberg was awarded the deferred prize for 1932. Okay, so these guys, most of these guys in this book got a Nobel Prize in physics in some way. So here's Einstein sitting at his chair in Princeton. About 1935, Einstein left Europe, fleeing, because he was a Jew, fleeing the Nazis, and ended up in Princeton, New Jersey at the Institute of Advanced Study. And there he didn't really do too much on quantum mechanics at that point. He was mostly interested in general relativity and in developing a theory of everything, or a grand unification theory. And so this is the light box experiments that Bohr and Einstein jousted about. And this was found on his study the night before he died. So they were debating this till the very end. Okay, now this is where it becomes more of a modern. We're leaving Bohr and Einstein behind. They were kind of in a philosophical debate all these years about the nature of quantum mechanics, and is it a physical reality or just a mathematical thing that works. This David Bohm, he knew Einstein, he worked there at Princeton, and he kind of came up with this idea of this hidden variables along with Einstein, and it turned out to be didn't work out that well. Now here's this John Stuart Bell. He's an Irish physicist who discovered Einstein and Bohr could not, a mathematical theorem. He did this Bell inequality that helped decide really who was right, or more right, or Einstein or Bohr. And this was about in the 60s when they came up with this. It didn't become popular until the 70s. Didn't get proven in the laboratory until the 80s. And this was fairly new when I was in graduate school. So I don't even remember studying this. I didn't study this. I noted I looked at my book to double check. It was just still being in development. So it's fairly new, I would say, since in the 80s. But so he kind of decided, he developed this theoretical model, and a bunch of other people validated it, that basically pointed to Bohr's approach as the Copenhagen interpretation is probably a little more correct than Einstein's, thinking that the theory is incomplete. The debate still is ongoing. It is not a done deal. There's still people, scientists all over the world kind of thinking about this. So this is one of the thought experiments that Bohr and Einstein jousted over. Einstein proposed this, and then Bohr refuted it and explained it. So it was just really about these two and the kind of development of quantum mechanics. It's really a good book if you want to understand the development of quantum mechanics and all the players involved. And this is kind of the timeline. It's got an extensive timeline that develops essentially all the major events that occurred in the development of quantum mechanics. And if you read that, you'll probably get a pretty good feel for what happened. And then it's got a glossary in the back in case some of the terms don't make sense to you. So that it turned out to be a really good book. I enjoyed reading it and learned a lot about it. And it's written by this guy, Max Kumar. He's a kind of a journalist. He has a degree in physics and philosophy. And that's why you probably would like this, because there's a lot of philosophical implications here into the nature of quantum mechanics. And that's primarily what Bohr and Einstein were jousting about. Well, overall, a good read. Learn a lot about the history of quantum mechanics, and it kind of takes you up into the present almost. So thank you for watching, and please give me some comments, give me a little feedback if you like these kind of reviews. I enjoy reading this book. Oh, I'm just getting a book in the mail next week, which is kind of a follow-on. This is called Hippies That Saved Physics, and it's got to do with that Bell. Basically, when he produced his theory back in the 60s, he didn't have the money to publish in a big name journal, so he published in some kind of offbeat journal that didn't get a lot of attention, this guy, and it took years for people to figure it out. And I don't know exactly what the hippies and the saved physics is all about. I'm going to read the book. I'll tell you about it if it's any good. But they kind of revived his theory, and it was really not until the 80s that it really became mainline physics. So thank you for watching. Hope you got a little bit out of this review of this book. It's a good read. Thank you. Bye.